There's only 5 that you need to, or that form the basis and foundation of Euclidean geometry. Again, I'm going to detail these on separate slides each, but I'll just kind of give about a heads up on them. Okay, the first postulate is the existence of a line. That has to be postulated. Right? So if you have 2 points anywhere, the first postulate assumes that we can draw a line through those 2 points. Okay, so again, there's no way to actually prove that. A line theoretically extends infinitely, which you can't measure. So you just have to make the assumption that that's true. Okay, the second postulate is if you took a portion of a line or a segment, we make the assumption that you can extend this segment infinitely in each direction to form a line so that all the properties that are associated with lines will be able to work on this as well. Now, what these first 2 postulates do is they introduce the use of a straight edge as one of the construction tools. Okay, so these first 2 postulates kind of bring in, or they identify why a straight edge is one of the construction tools. You don't need to measure the lines, you don't need to measure the segments, you simply need to extend them out and draw straight lines. And so that allows you to use a straight edge as one of your construction tools. Okay, the third postulate, and you do need to know the order of these 2, so you need to be able to write these in order. The third postulate is existence of a circle, and what that states is if you have a fixed point in a given distance, that there does exist a circle that passes through that, or that has the properties of that fixed point or the center in the given distance radius. Okay, this third one here by itself introduces the compass as a construction tool. And again, that's really about it. It just allows you to introduce this. It doesn't talk about the measurements involved, just that you can construct a circle. Right, the fourth postulate is the only introduction of magnitude or measurement. And again, it just specifically gives you a comparison value. It doesn't give you the actual measures, but it just says that all right angles are equal. So what that says is no matter how a right angle is oriented, or how big the sides are, right angles will always be equal to each other. Okay, so this is unlike the coordinate geometry where different angles can be located on different parts of a plane with different coordinates. And this is just the introduction of magnitude, meaning that the right angles are what you will have comparisons to. So you'll have angles that are less than right angles, which are acute, angles that are greater than right angles, which are obtuse, but they didn't specifically talk about the measurements of them, just that how they compare to right angles. So this is the one introduction to measurement. And then finally, the parallel postulate. It has some somewhat confusing wording, but the gist of it is if you have 2 lines, and a third line passes through those 2 lines in such a way that the same side interior angles are less than 180 degrees. So if A plus B is less than 180, then what the parallel postulate says is these lines will converge on that side. And so basically what it's saying is if it's not the A plus B that's less than 180, what if it was C plus D is less than 180? Then the lines will converge on the left side of this. And now the reason it's called the parallel postulate is because what happens if neither of these cases is true? What if A plus D or A plus B is not less than 180, and what if C plus D is not less than 180? Yeah, then they're all right angles, which means the lines are going to be parallel. Okay, so if it's true that A plus B is equal to 180, then the lines are parallel. Right? And again, I'll talk a little bit more specifically about this, but that's what the parallel postulate relates. All right, so the next 5 slides here, I'll go through each of these postulates independently, and we'll talk just a little bit more about each one. All right, so the first postulate, again, you need to know the names of these, and you need to know their order. So the first postulate can be referenced as existence of a line, and it postulates that if you have, again, the historical wording was to draw a straight line from any point to any point. Okay, so what that means is it postulates the existence of a straight line. Okay, so even though the definition is impossible to defend or prove, you have to imagine that you can create a straight line. It also implies uniqueness. It's to draw a straight line. So it's a unique straight line that connects any 2 points. So it's basically saying that between any 2 points there exists one and only one straight line. Okay, and again, it introduces the use of a straight edge as one of the construction tools. All right, the second postulate was extension of a line. So now you start with a finite portion. So again, the historical wording is to produce a finite straight line continuously in a straight line. So the finite straight line is what we call a segment. So what this says is that you can extend a segment in either direction, again, using a straight edge. And just like with the uniqueness of a line, what this kind of implies is the uniqueness of a segment. And no 2 straight lines can have a common segment. And again, it allows you to extend a segment infinitely in each direction. All right, so postulate 1 and 2 introduce the use of a straight edge. Postulate 3 introduces the use of a compass. Historical wording is to describe a circle with any center and distance. And so just given a center, fixed point, and a distance, which would give you a point on the circumference, you can draw a circle. And again, those just allow you basically to introduce the constructions that we'll use to, or that were used to defend or justify many of the relationships. All right, once we move to postulate 4 introduces the idea of magnitude. And so again, even though there's not an actual measurement, it involves measurements. And what it's saying is that all right angles are equal. So no matter how they're oriented, how big their sides are, how long their sides extend, it asserts that a right angle has a specific magnitude, which we now refer to as 90 degrees. And then other angles could simply be compared to that, either greater than a right angle or less than a right angle. Again, coordinate geometry changed this and actually gave specifics and allowed you to make distinctions among different angles because they could be located in a different part of a plane. But at this time, historically speaking, they didn't make that distinction. All right, and then finally, the last one, here's the historical wording. Again, could be somewhat confusing, but I'll draw it in or illustrate it as I read through. Okay, so that if a straight line falling on 2 straight lines, so here's 2 straight lines, if a straight line falls on those, making the interior angles, which I'll call A and B, on the same side less than 2 right angles. So once again, if A plus B is less than 180, then the 2 straight lines, if produced indefinitely, meet on that side on which the angles less than the 2 right angles. So basically what this is saying is if A plus B is less than 180, then the lines converge at the right. If instead C and D were less than 180, so if that condition was met by the other set of same side interior angles, then these lines would converge to the left. And then it leaves open the interpretation that what happens if neither of these is true. So if A plus B is not less than 180, instead it's equal to 180, then these lines will never converge. Which means they are parallel. Okay, so again, the implications for this is that two straight lines can't enclose a space, right? They're either going to converge to the left, to the right, or they don't converge at all and are parallel. And so the interpretation, if we take this historical wording and we make it a little more understandable in today's language, it's just that two straight lines will converge in the direction for which the sum of their same side interior angles is less than two right angles. Okay, so we are going to stick with this historical interpretation. We will actually be using this in proofs to set up and to justify some other types of proofs. So we will use this historical description. And now many textbooks will have changed this postulate slightly, and they've changed it. Again, this is the same thing that we just talked about, but many textbooks have changed it into the following relationship. The parallel postulate can also, or has also been interpreted as meaning if you have a line and a point not on that line, the parallel postulate states there's one and only one line that can pass through that given point that's parallel to the given line. Okay, so you may also see that as the parallel postulate, which states through any point not on a line, there exists one and only one that passes through that point that is parallel to the given line. Okay, so again, we are going to stick with this traditional definition. Okay, but just to be aware that this is another way that that's interpreted. All right, so those are the 5 postulates. You do need to know them. You need to know 1, 2, 3, 4, and 5. You need to know how they're ordered, which ones are which ones introduce the construction tools.